There's an engine that General Motors designed in 1960 that could have revolutionized the entire automotive industry. It weighed 400 pounds less than cast iron V8, more powerful per pound, and perfect for the fuel crisis that was coming. GM executives killed it deliberately, not because it didn't work, but because it worked too well. And the decision to sabotage their own engineering destroyed GM's reputation for the next 3 decades. The engine was the Buick 215 cubic inch aluminum V8. It debuted in 1961 Buick Specials, Oldsmobile F-85, and Pontiac Tempests. Automotive journalists called it a masterpiece. 155 horsepower from 318 pounds. The lightest, most advanced V8 in production. It should have defined the 1960s. Instead, GM sold the entire design to British Rover for $75,000 in 1965 and pretended it never existed. Rover turned that same engine into a legend. They used it in Range Rovers for 40 years. It powered Morgan sports cars, TVR supercars, and Land Rover Discoveries. The British treated GM's abandoned engine like a national treasure. Meanwhile, GM went back to building 600-pound cast-iron boat anchors that got 12 miles per gallon and destroyed their brand when fuel prices exploded in 1973. But here's what should enrage anyone who's ever bought a GM vehicle. The aluminum V8 didn't fail. GM sabotaged it deliberately through incompetent manufacturing, denial of obvious quality control problems, and refusal to fix issues they knew existed. They destroyed their own breakthrough technology to protect their existing cast-iron foundries, their parts supplier relationships, and their executives' short-term bonuses. And when the engine developed problems they caused, they blamed the design and killed it rather than admit they screwed up the manufacturing. This is the story of how GM had the engine that could have dominated the 1960s and 70s, deliberately destroyed it through corporate corruption and incompetence, then watched competitors succeed with the exact same design they abandoned. The Buick 215 wasn't a prototype or experimental engine. It was a fully engineered, production-ready masterpiece that represented everything Detroit should have been building. All aluminum block and heads, thin wall casting technology, compact dimensions, 318 pounds complete with accessories. A cast iron V8 of similar displacement weighed 650 pounds. The weight savings were revolutionary. Removing 300 pounds from the front of a car changes everything. Handling improves because weight distribution balances. Fuel economy increases because you're not dragging around extra mass. Acceleration improves because power-to-weight ratio increases. The 1961 Buick Special, with the aluminum V8, was faster, more efficient, and better handling than anything GM made with cast iron. The engineering was brilliant. Thin wall casting meant the aluminum block walls were only 0.15 inches thick compared to 0.25-0.35 inches on cast iron blocks. This saved weight while maintaining strength because aluminum, despite being lighter, piece has sufficient tensile strength when properly cast. The cylinder bores were treated with a silicon aluminum coating that provided wear resistance without heavy cast iron sleeves. Power output was impressive. The base 155 horsepower version made 1.97 horsepower per cubic inch, which was excellent for 1961. The higher compression versions made 185 horsepower. Compare this to Chevrolet's 283 cubic inch cast iron V8, making 170 horsepower, or 0.60 horsepower per cubic inch. The aluminum engine was dramatically more efficient in both weight and power density. Automotive journalists loved it. Car and Driver called it the most significant engine development of the decade. Road and Track praised its smooth power delivery and weight distribution benefits. Motor Trend predicted it would force the entire industry to shift to aluminum. They were right about the technology. They were wrong about GM's willingness to manufacture it properly. Here's where corporate corruption destroyed brilliant engineering. The aluminum VEV8 required different manufacturing processes than cast iron. Tighter tolerances, better quality control, more precise assembly. Cast iron is forgiving because it's heavy and rigid. GM knew this. They had the engineering data. They chose to ignore it. GM built the aluminum V8 scenes on the same assembly lines. No additional training, no upgraded equipment, no enhanced quality control. The results were predictable and catastrophic. Aluminum expands at different rates than cast iron. The head gaskets and block-to-head interface required specific torque sequences and specialized gasket materials. GM used standard cast iron gaskets and torque procedures. Coolant leaked between the block and heads. Customers complained. GM blamed the aluminum design rather than their manufacturing process. The second problem was bearing failure. Aluminum blocks require more precise machining tolerances for main bearing journals. GM's cast iron tooling produced acceptable tolerances for cast iron, but marginal tolerances for aluminum. Some engines had bearing journals that were slightly out of spec, not enough to fail immediately, but enough to cause premature wear. Engines developed bearing knock at 50,000 pounds and 70,000 miles. GM blamed the aluminum design. The third problem was cylinder bore wear. The silicon coating on the cylinder walls required specific break-in procedures and oil specifications. GM didn't inform dealers about either requirement. Owners drove new engines hard immediately without proper break-in. They used standard oils instead of the specified formulations. The silicon coating wore prematurely. Engines burned oil and lost compression. GM blamed the aluminum design. But here's the smoking gun that proves sabotage rather than bad design. When British Rover bought the tooling and design in 1965, they manufactured the exact same engine with proper aluminum casting procedures. They fixed the head gasket issue by using different gasket materials and torque specs. They fixed the bearing issue by improving machining tolerances. They fixed the cylinder wear issue by specifying correct oils and break-in procedures. The Rover version was bulletproof. It powered Range Rovers that routinely exceeded 200,000 miles. Morgan used it in sports cars that were thrashed on racetracks. TVR pushed it to 300-plus horsepower in supercar applications. The same basic design that GM claimed was fatally flawed ran for decades in British vehicles with minimal problems. The engineering was fine. GM's manufacturing was garbage. The real question is why GM didn't fix the manufacturing problems they caused. They had the engineering knowledge. They knew what was wrong. Rover proved the design was sound by manufacturing it correctly. So why did GM give up on their own breakthrough technology after just 4 years? The answer is corporate corruption and financial incentives that prioritized short-term costs over long-term competitiveness. First, GM had massive investments in cast iron foundries. They owned foundries across Michigan, Ohio, and Indiana producing cast iron engine blocks. These foundries employed thousands of workers and represented billions in capital investment. Switching to aluminum meant those foundries became obsolete. The executives who approved those foundry investments would look incompetent. The unions representing foundry workers would fight the transition. So GM chose to protect existing infrastructure instead of embracing superior technology. Second, GM's parts suppliers built their businesses around cast iron engines. Gasket manufacturers, bearing suppliers, machine shops that did engine rebuilds, all were set up for cast iron. Aluminum required different parts, different procedures, different business models. These suppliers pressured GM to stick with cast iron because switching would cost them money. GM executives prioritized supplier relationships over engineering excellence. Third, the aluminum engine cost more to manufacture correctly. Cast iron was cheap and forgiving. Aluminum required better quality control, tighter tolerances, and more expensive materials. This hurt profit margins. GM executives were compensated based on quarterly profits. Killing the aluminum engine and sticking with cast iron improved short-term numbers. That the decision would destroy GM's competitiveness a decade later didn't matter, because those executives would be retired by then. But here's the most damning evidence of deliberate sabotage. Internal GM engineering documents from 1962 to 1963 identified all the manufacturing problems and proposed solutions. Engineers specified exactly what needed to change to make the aluminum V8 reliable. Upgraded quality control, different gasket materials, revised assembly procedures, better machining tolerances. The solutions weren't complicated or expensive. GM management rejected every recommendation. Not because the solutions wouldn't work, but because they required admitting that manufacturing quality was the problem. Admitting that meant taking responsibility for warranty claims, paying for retrofits, and acknowledging executive failure. Instead, they blamed the design, declared aluminum technology premature, and went back to cast iron. The decision was made in 1963. By 1964, GM was already phasing out the aluminum V8. By 1965, they sold the design to Rover for $75,000, pocket change for a company GM size. The aluminum V8 was gone from American GM vehicles completely. The 1973 oil crisis exposed how catastrophically wrong GM's decision was. When gas prices quadrupled overnight, American consumers suddenly cared desperately about fuel economy. GM's entire lineup was built around heavy cast iron V8s that got 10 to 12 miles per gallon. They had no efficient alternatives ready. Efficient engines destroyed GM's market share. Honda, Toyota, and Datsun were building aluminum four-cylinder engines that weighed less than 300 pounds and got 30 miles per gallon. GM was still building 600-pound cast iron V8s that got 12 miles per gallon. The weight penalty alone cost 3 to 4 miles per gallon. If GM had continued developing the aluminum V8, they would have dominated the 1970s. A 318-pound V8 getting 20 miles per gallon would have crushed Japanese four-cylinders in the American market. GM could have offered V8 power with four-cylinder efficiency. Instead, they watched their market share collapse from 46% in 1970 to 35% by 1980. But the damage went beyond lost sales. GM's reputation was destroyed. They became known as the company that built unreliable, inefficient, outdated vehicles. The aluminum V8 debacle was part of a pattern. The Corvair they abandoned after lawsuits. The Vega aluminum four-cylinder they botched through bad manufacturing. The diesel V8 they rushed to market without proper testing. Every failure followed the same pattern as brilliant engineering destroyed by corporate incompetence and corruption. Meanwhile, Rover was thriving with GM's abandoned technology. The aluminum V8 became Rover's signature engine. Range Rover built their entire brand reputation around it. The engine's lightweight made Range Rover the first luxury SUV with genuine off-road capability and on-road performance. By 1980, the Rover V8 was legendary for reliability, while GM's reputation was in ruins. The irony is devastating. GM designed the engine. GM built the prototypes. GM proved it worked. Then GM sabotaged their own creation through deliberate manufacturing incompetence, sold it to a British company for nothing, and watched that company succeed with GM's own technology while GM collapsed. The aluminum V8 sabotage wasn't an isolated incident. It was part of GM's corporate culture that prioritized short-term profits and executive bonuses over engineering excellence and long-term competitiveness. The same pattern repeated throughout the 1970s and 80s with catastrophic results. The 1971 Vega was supposed to be GM's answer to Japanese imports. Engineers designed an innovative aluminum four-cylinder engine. Management rushed it to production without proper development. The engine had the same issues as the aluminum V8. Inadequate quality control, improper break-in procedures, wrong oil specifications. It failed massively. GM blamed the design instead of their manufacturing. The 1978 Oldsmobile diesel V8 was supposed to compete with European diesels. Engineers warned it needed more development. Management rushed it to market to meet Ka fuel economy standards. The engine was a converted gasoline engine with inadequate strengthening and poor fuel system design. It failed catastrophically. 50,000 engines failed under warranty. GM paid $200 million in settlements. Again, brilliant concept destroyed by executive impatience and manufacturing incompetence. The pattern is always the same. Engineers design advanced technology. Management refuses to invest in proper manufacturing. Engines break. Management blames the design. Engineers are ignored. The technology is abandoned. Competitors implement the same technology successfully. GM loses market share. But here's why the aluminum V8 was the most damaging failure. It happened first. It established the pattern. And it happened when GM was at peak dominance with 46% market share and unlimited resources. If they couldn't make aluminum engines work when they were rich and powerful, they had no chance when they were struggling and desperate in the 1980s. The aluminum V8 also proved that GM management was more interested in protecting existing investments than embracing new technology. The foundries, the suppliers, the assembly lines all represented sunk costs that executives were emotionally attached to. Admitting that aluminum was better meant admitting they'd been wrong. Corporate ego prevented GM from accepting that their massive infrastructure was obsolete. By 1967, the Rover V8 was in production with none of the reliability issues that plagued the GM version. The engine became legendary. Range Rover launched in 1970 with the aluminum V8 as standard equipment. The engine's lightweight made the Range Rover possible, a vehicle that could be luxurious on-road and capable off-road because it wasn't dragging around a 600-pound cast-iron anchor in the front. Range Rover defined the luxury SUV category that would dominate the automotive market for the next 50 years. Morgan, the boutique British sports car manufacturer, used the Rover V8 from 1968 onward. TVR, another British sports car company, used modified versions producing up to 350 horsepower. MG used it in the MGB GT V8. Land Rover used it across their entire range. The engine that GM declared a failure powered the British automotive industry for 4 decades. Production finally ended in 2006, 45 years after GM introduced it and 41 years after GM abandoned it. The final version displaced 4.6 liters, made 218 horsepower, and was still being praised for reliability and smooth power delivery. The same basic architecture GM killed in 1965 was still competitive in 2006. Total production by Rover and subsequent owners exceeded 2 million engines. 2 million examples of GM's failed design built over 4 decades with excellent reliability. Meanwhile, GM spent those same 4 decades building increasingly obsolete cast-iron engines, watching their market share collapse and eventually declaring bankruptcy in 2009. GM's decision to kill the aluminum V8 cost them far more than lost sales. It cost them credibility, engineering talent, and market position they never recovered. The engineers who designed the aluminum V8 learned that brilliant work didn't matter if management wouldn't support it. Many left GM for competitors or foreign manufacturers where their skills were valued. GM's brain drain started in the 1960s when top engineering talent realized innovation was punished rather than rewarded. The message to GM's remaining engineers was clear. Don't take risks. Don't design anything that threatens existing infrastructure or supplier relationships. Just make incremental improvements to existing technology. This culture of mediocrity defined GM for the next 50 years. Customers learned that GM couldn't be trusted with advanced technology. The aluminum V8's problems became legendary, repeated in consumer reports and car magazines for decades. Even though the problems were manufacturing issues GM caused, the reputation stuck. GM can't build aluminum engines became conventional wisdom. When GM finally started using aluminum again in the 1990s, customers were skeptical because of the 1960s failure. But the biggest cost was strategic. The aluminum V8 could have positioned GM to dominate the efficiency-focused 1970s. Instead, they entered that decade with the oldest, heaviest, least efficient engine technology in the industry. Japanese manufacturers ate their lunch. European manufacturers took their premium market. Domestic competitors like Ford adapted faster. GM's market share declined from 46% in 1970 to 19% by 2009 when they declared bankruptcy. You can draw a straight line from the decision to kill the aluminum V8 to GM's eventual collapse. Not because the engine alone would have saved them, but because it exemplified the corporate culture that destroyed them. Short-term thinking, refusal to acknowledge mistakes, protecting obsolete infrastructure, blaming engineers instead of management, abandoning superior technology to protect executive egos. The aluminum VF8 story is taught in business schools as a case study of how not to manage innovation. When they protect sunk costs instead of embracing new technology, when they blame designers for manufacturing failures, when they let ego override engineering excellence, GM had the engine. They had the technology. They had the resources. They sabotaged themselves through incompetence, corruption, and short-term greed. Then they watched a British company succeed with their abandoned technology while GM collapsed. The Buick 215 wasn't a failure. 2 million Rover V8 sell over 45 years proved the design was brilliant. GM's manufacturing was the failure. GM's management was the failure. GM's corporate culture was the failure. And rather than fix what they broke, they blamed the engineers, killed the engine, and condemned themselves to decades of obsolescence. That's not bad luck. That's not market forces. That's deliberate sabotage of their own breakthrough technology, because admitting mistakes and fixing manufacturing was harder than abandoning innovation and going back to what they knew. The aluminum V8 could have saved GM. Instead, it became the symbol of everything wrong with the company that eventually destroyed them.